Hello, and welcome to Jeff Kagan Interviews, where we speak with newsworthy executives to discuss their companies, their technologies, their ideas, and the changing industry. I'm Jeff Kagan. This program is designed to educate investors, customers, workers, and the media to better understand our changing world and the new and real opportunities all around us. Today we have with us Dan Hodges, Chairman and CEO of TM Technologies. Welcome, Dan.
Thanks, Jeff, for having me aboard.
Anytime. TM Technologies is a wireless company offering dramatic data improvements for existing networks. They use TM, Transpositional Modulation. They believe their technology can prevent or at least delay the onset of the wireless bandwidth crunch that we're all experiencing today on our wireless networks. So before we get started, Dan, why don't you take a moment and introduce yourself to the audience?
Great, thanks, Jeff. Yeah, Dan Hodges. About a dozen years ago, TM Technologies was founded. It is my 12-year overnight success. It's taken a long time to get where we are, but it is now starting to become general knowledge, Jeff, that we do have something very special here. We've seen a flurry of activity just in the last 2 months alone. So pretty excited about it. TM is certainly a disruptive communications technology firm founded on cutting edge principles of see what's going to occur in the next few years, if you will, that is not doable right now and find a way to stopgap that. We started that with TM having a little bit of insight and foresight, and here we are 12 years later, and it is still the need for bandwidth and security is still more pressing than ever.
Well, thank you. And I agree. You know, the wireless networks have been stretched to try and meet the growing demands of wireless data. You know, in the old days, we never really had to worry about wireless data. But in the last 10, 20 years, with all the the iPhones and Androids and tablets and all the devices that we use, everything from the refrigerator to everything that we have in the house for streaming and in the offices, it's putting an enormous strain. The bandwidth that we use, the spectrum that we use, is very limited, even though we have more and more data. So that's the challenge, and that's what you do. That's what you focus on. So let's get into this and see if we can help the audience understand. So first question, has 5G met its original performance and efficiency expectations?
Well, I'd say from inception, the 5G struggled with balancing this private, commercial, and government customers' high data requirements with, of course, low latency expectations. The whole idea behind it, 5G, was to be able to put everything on one network and then just share those physical resources of spectrum. But in this increasingly dense signal environment, we have to be able to use all available wireless communication spectrum to do it right. Plus the various installed 5G networks that they have grossly different performance and capacities, even though they share the same standards. In addition, complex spectrum sharing techniques between companies and networks are being used to try to increase data throughput rates, but the high computing overhead and operational costs, they've only limited us to modest improvements. So achieving these spectral efficiencies in order to share all this spectrum and thereby pass data to the various devices that are linked in with it, the idea is to make more with less to meet the demand, and that of the next generation 6G and beyond that even. It's literally $1 trillion quest. To answer your question succinctly, though, without bloviating, 5G presently is just not delivering as it originally promised.
Yeah, I hear that all the time. So are you saying that spectral efficiency is inadequate? Is that holding us back?
Well, to start with, we have to maximize spectral efficiency at the physical layer of the wireless network radios. That is, we have to use every available frequency slice of this 5G spectrum band. There are physical limitations, and you'll hear lots of claims, and when you put it to the litmus test, they just don't match up. It can't happen. But a big part of what 5G does is to maximize its potential is to try and make it more efficient in little manners, and sometimes a 1 or 2% efficiency increase is considered magic. Otherwise, it just can't deliver the speed and throughput it promises. So let's see if I can find an analogy. If you compare, say, 5G to a fast food joint, if your cooking processes and labor overhead are way too complex, or people are overtasked, or things are bloated to allow preparation and delivery of your burgers, like you promised, you can't get customers their food orders timely, and the queue or the line of cars waiting at your driving window stacks up. Everyone gets frustrated, and quality suffers, everything suffers. And such is the case with 5G. It was supposed to be the master network to which all IoT devices could connect to, flow data through, operate seamlessly within. And as you can clearly see now, it just hasn't been able to do that. The good news is that we've now proven TM's patented methods can overlay these existing 5G signals at the physical layer and increase data efficiency. In one test we did up to 40%, while hiding itself securely within the signal so you can't even see it. And oh, by the way, it reduces what engineers call peak average power ratio all at the same time. What that does is it makes it even more efficient, makes everything else within the 5G system work better as well. This is a win-win-win situation, and it's simply unheard of and even unimaginable up till now. In addition, our patented simultaneous transmit and receive, or it's called STAR technology, often referred to as in-band full duplex, that's also demonstrated up to a doubling of data rate in the fixed wireless applications.
So how has TM implemented these new cognitive spectrum optimization techniques?
Well, good. I get to put on my salesman hat.
Yeah.
I'm glad you asked. TM's developed a suite of novel complementary technologies, and these enable this dynamic cognitive optimization. That means it sees, understands, and creates a solution within the communications in real time. And it does it in these congested, contested, and spectrum constrained environments that we operate in with wireless. As we just discussed, transpositional modulation enables this secure, I don't like to say covert, but it's secure, obfuscated is a better word, communications. And it significantly at the same time increases 5G spectral efficiency, data rates, area traffic capacity without using any additional spectrum. Traditional techniques to improve this efficiency and boost 5G data speeds and network capacity, like higher order, what they call QAM modulations, or MIMO antennas, carrier aggregations. All these are considered groundbreaking. Again, as I mentioned before, if you could just get a few percentage points of improvement, but these aren't enough to fix what's broken. And 6G won't be enough to fix what's broken. We need a fundamentally different chain. And TM now steps in by using this adaptive spectral monitoring to identify and exploit room within existing signals to add additional non-interfering channels of communication. So we start by cleaning up the signal sidebands and even space underlying the main signal. I don't know if you've seen a signal. I call it a Bart Simpson head. It goes up like a sine wave, and then it does this, and it comes down like the other. We clean up the spaces on the side and underneath the main signal lobe using our digital predistortion methods. And that removes all the noise in the signal that you got to filter out, and it causes delays and whatnot. And we clean it up and then overlay additional data paths in the same frequency band at the same time without interfering with the original signal. It'd be like adding more lanes of traffic on a highway without widening it, nor using any space in the original lane to do it. Well, how does it do it? Well, our completed 5G test results using modern software-defined radio platforms confirms that, as I said, by up to 40%. Like I mentioned before, we also significantly improve cell coverage, cell edge performance by reducing the peak to average power ratio. So TM holds over 70 granted and pending patents to be able to do what it does, and it's taken, as I said, a dozen years to get here, but it is earth-shaking.
This is an important. Give me a few use case examples for TMT's cognitive spectrum optimization technologies.
Sure. Well, our CSO, or cognitive spectrum optimization, can be used in both private and public networks where spectrum availability is constrained or congested or compromised. The algorithms can be directly embedded into a variety of 5G modem, transceiver, or integrated circuits, or uploaded as firmware into deployed network radios with programmable chips. So some immediate network use cases, just to name a few that come to mind, are private health networks, smart manufacturing networks, distribution and logistics, port and intermodal networks, field operations like in the oil field, or public utility communications, and of course, we are speaking quite urgently with the large mobile networks that operate within the U.S. and a couple foreign countries as well.
So AI is already changing some industries, that we know it's positioned to transform many others. It's a transformative technology. So what do you see as the relationship between AI and your technology, TM? In other words, where do you see your company creating an impact with AI?
TM has the potential to significantly impact AI. There's a lot more to AI than folks think about, and it requires a lot of data movement to pre-train models, test them, and then point them to their taskings. So since TM Technology's modulation approach allows for much more data to be transmitted over the same signal, yes, we impact it greatly. This spectral efficiency is crucial for AI systems. Again, they rely on huge volumes of data to train models and make decisions. So by enhancing the amount of data that can be sent without needing more spectrum and doing it fast, AI applications can operate more effectively and at a larger scale, especially in environments where bandwidth is limited. Lastly, with a push towards edge computing, where data processing happens closer to the data source rather than in centralized data centers, efficient and secure is a big bellwether there, data transmission becomes even more crucial. TM Technologies' modulation methods, they enhance the capability of edge devices to communicate effectively, supporting more complex AI operations at the edge of the network. So overall, the impact of TM and our secure and spectrally efficient modulation methods on AI hinges on our ability to enhance data transmission capabilities in terms of speed, volume, and security. And these improvements are vital for the continuing integration and expansion of AI in various domains, ensuring faster, more reliable, and safer AI-driven solutions. AI will work. AI is great, but it's a tool, and it's a tool that requires a lot for it to work well. And it's all the promises that it brings are not going to be realized absent better data carrying capacity, and that's what TM offers.
That's true. We talk about AI all the time, but we don't really talk about what's needed to make it work. And we just assume that it's going to work. All right, so let's wrap up. One last question. You've talked about how important data security is to the existing wireless networks, but I understand that TM is also working on another high bandwidth technology that exists outside of the networks. Can you tell us a little bit about that?
Sure, absolutely. And we haven't really released information on this yet, so I'll try to keep it within the bounds of so I don't get shot by my own staff here. But again, thanks for bringing it up. We're really very excited about this. It seems the whole world's moved to the cloud, and of course that's very convenient. But it also dependent, that cloud, on an unbreakable chain of connectivity from the device transferring the data through public or private wireless networks to a cloud data center, possibly with AI resources, and then back to the user in seconds. Of course, we talked about our cognitive spectrum optimization, but there are many instances where a user's physical proximity is and should be the prime factor in whether or not digital information is exchanged. And for example, transactions via NFC, near field communications, is a good example. But the flow rate of data is so limited, though, in NFC, it's only primarily used for credit card transactions and small bits of contact information. Well, we've developed a method to massively increase the data transfer rate between near field devices. And we're currently calling it TM NFC Plus. This technology allows for data transfer speeds orders of magnitude higher than current NFC data transfer rates. That right now they're less than a megabit per second with our current standards and our current technologies used within the standards. With our NFC Plus, a user with permission could capture or transfer huge amounts of data with just a tap, or simply by being within close proximity to an NFC Plus enabled device. And we're integrating one right now into a use case in the marketing area. This could even work in a way where an unpowered TM NFC tag, basically it gets inductively powered on by a user's mobile device. We all know where you can charge using this. Well, this works in reverse. And so we patented this capability to put this up against a tag that has no power of its own, but holds a lot of data and an executable file. What happens is you put it up against that tag, it powers and then pulls that information, that data, that program, that application right onto your phone. We think this has significant applications to augment everything from HIPAA compliant health data transfers to industrial automations, inventory controls, even in proximity-based marketing and tourism applications. So we think it's wise to invest in digital technologies that are instantiated in the real world, where proof of presence in space-time is key to authenticating access to and the transfer of information at that location. What I mean by that is you're starting to see point of presence become more popular, more important. We've decentralized everything to a cloud now, which actually is a centralization. And what we're seeing popular now is where people want to have proof that they were at a certain location and did certain things, and were able to keep record of their visits, for instance, in hospital and tourism, hospitality and tourism. So we're truly excited to start getting these examples of this broad NFC technology out in the field real soon.
Funny, listening to your explanation, I'm remembering all of the visions that I had over the past several decades about what the future would look like. And this is definitely very exciting. I can't wait till you can talk about it further and make one of the announcements. We'll talk again.
Thanks, Jeff.
I would like to thank you, Dan. I can see how we really need to remain engaged to continually solve this limited data spectrum problem that we've been wrestling with for a while. And I look forward to continuing the conversation again. And to the viewer, I'd like to thank you as well for your time and interest. Remember, these interviews can be seen on Twitter, X, LinkedIn, and YouTube. Just search for Jeff Kagan Interviews. Until next time, thank you and goodbye.